I thank all of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the question paper CSIR National Eligibility Test held in the month of June 2023. This question is from the section Real Analysis and it is related to the uniform convergence of sequence of functions. And this question is from the part C, which is a multiple select question. There can be more than one answer and it carries 4.75 marks. The question ID is 704063. This question is suitable for all these examinations. Right. The given question is, which of the following are true? Options. We are given 4 options. Option 1. For n greater than or equal to 1, the sequence of functions fn from the open interval to itself defined by fn of x is equal to x power n is uniformly convergent. In option 2, similarly, we are given a sequence of functions defined by fn of x is equal to x power n by log of n plus 1, whether it is uniformly convergent or not. Option 3 is about the uniform convergence of the sequence of functions fn defined by fnx is equal to x power n by 1 plus x to the power of n. In option 4, the sequence of functions fn defined by fnx is equal to x power n by 1 plus n x to the power of n is not uniformly convergent. Right. In the fourth, it is not uniformly convergent. In options 1, 2, 3, whether they are uniformly convergent or not is given. Let's now discuss the solution of the problem in detail. We go for option 1. We have a sequence of functions fn from the open interval 0, 1 to 0, 1 defined by fnx is equal to x to the power of n. The question is whether this sequence is uniformly convergent or not. We have fnx given by x to the power of n, where n belongs to set of natural numbers, x belongs to the open interval. Agreed. Now, for each x belongs to the open interval 0 to 1, what is the limit of this fnx? So, for each x belongs to the open interval 0 to 1, limit n tends to infinity of fnx is equal to limit n tends to infinity of x to the power of n, and it is 0 because x belongs to 0 to 1. And this is true for all x, and let us say this is equal to f of x, where f of x is 0 for each x belongs to 0 to 1. And this f is called the limit function. Right. Now, this says the sequence fn converges pointwise to f. This is the pointwise convergence of the sequence of functions fn. And it converges pointwise to a function f. Right. To talk about uniform convergence, we remember a test, that is the M test. Sometimes it is called MN test. M test for uniform convergence of sequence of functions. So, this states, let D be a subset of R and the sequence Fn is a sequence of real valued functions which is converging pointwise to a function f on D. let Mn is equal to supremum of mod of Fnx minus Fx, where supremum is taken over all x belongs to D. Then the sequence Fn is uniformly convergent on D to F if and only if limit n tends to infinity of Mn is equal to 0. So we come back to our problem. Now talk about Mn, that is the supremum taken over all x belongs to the open interval 0 to 1 of Fnx minus Fx. This is supremum of mod of Fnx. Fnx is given to be x to the power of n minus f of x is 0. So mod of x to the power of n. But we have written x to the power of n only because for each x belongs to 0 to 1, x to the power of n is positive. Therefore, modulus is not necessary. Now, what is the supremum of x belongs to 0 to 1 of x to the power of n? So, it takes various values of x belongs to 0 to 1, and from among them, you have to get the supremum. The supremum will be 1. Right. Now, limit n tends to infinity of Mn. Thus, we get a sequence Mn, which is a constant sequence. Therefore, limit n tends to infinity of Mn is equal to 1, which is not equal to 0. So, call back to M test, and is uniformly convergent if and only if limit n tends to infinity of Mn is equal to 0. But it is not 0. Limit n tends to infinity of Mn is not 0. Therefore, by M test, for uniform convergence of the sequence of functions, the given sequence Fn is not uniformly convergent. Therefore, the option 1 is not true. So let's move to the next option. Option 2. This time you have Fn defined by Fnx is equal to x to the power of n by log of n plus 1. Now we have Fnx, and limit for each x belongs to the open interval 0 to 1, limit n tends to infinity of Fnx is equal to limit n tends to infinity of x to the power of n by log of n plus 1. So limit n tends to infinity of x to the power of n is 0 because x belongs to the open interval 0 to 1. And that is equal to f of x, where f is a limiting function. F of x is 0 for all x belongs to the open interval 0 to 1. So that means the given sequence Fn converges pointwise to f. This is the pointwise convergence of the sequence converging to f. Now let's call back M test, and for that we want the Mn, that is the supremum of x belongs to 0 to 1 mod of Fnx minus Fx, and f of x is 0. Fnx is x to the power of n by log of n plus 1. So that is supremum of x to the power of n by log of n plus 1. And when you take the supremum of x to the power of n, when x belongs to 0 to 1, it is 1 by log of n plus 1. So we got the sequence Mn. So limit n tends to infinity of Mn is limit n tends to infinity of 1 by log of n plus 1. That is 0. Yes, 0. So by M test, the given sequence of functions is uniformly convergent on the open interval 0 to 1. Agreed. So that means the option 2 is true. Right. We move on to the next option. Option 3. This time our Fnx is given to be x to the power of n by 1 plus x to the power of n. We take that Fnx, and for each x belongs to the open interval 0 to 1, limit n tends to infinity of Fnx is limit n tends to infinity of x to the power of n by 1 plus x to the power of n, which is 0 because x belongs to 0 to 1, right? And which is equal to f of x, the limiting function. F of x is equal to 0 for all x belongs to the open interval 0 to 1. Calculate now That means the sequence Fn converges pointwise to f, and f is the limiting function. Right. Let's calculate the Mn. Mn is supremum of x belongs to 0 to 1 mod of Fnx minus fx. That is supremum of x belongs to 0 to 1 x to the power of n by 1 plus x to the power of n. Right. Now we cannot find out because these are the sequence of the elements. The sequence of elements of x to the power of n are there. We can't, by 1 plus x to the power of n is there. We can't find out supremum by seeing it. So for that, we take phi of x is equal to x to the power of n by 1 plus x to the power of n. Now take its first derivative and see whether it is positive or negative. And if it is positive, for all x belongs to the open interval 0 to 1, it is monotonically increasing function, and thereby supremum can be found out. So take a phi of x and differentiate with respect to x using quotient formula of differentiation. Right. We are very familiar, and simplify. You will get nx to the power of n minus 1 by 1 plus x to the power of n whole square. And this is greater than 0 for all x belongs to 0 to 1. Right. So therefore phi of x is a monotonically increasing function because it is greater than 0. So when it is a monotonically increasing function, we can find out supremum of phi x. Supremum of x to the power of n by 1 plus x to the power of n when x belongs to 0 to 1. Supremum is 1 by 1 plus 1. That is 1 by 2. The supremum of x to the power of n when x belongs to the open interval 0 to 1 is 1. So it is 1 by 2, which is constant. So, right. So that means Mn is equal to 1 by 2, which is constant. Limit n tends to infinity of Mn is 1 by 2 because it is a constant function which is not equal to 0. Using the M test, it is not uniformly convergent. So option 3 is not true. We go to the last option, option 4. This time we are given the sequence Fnx given by x to the power of n by 1 plus n times x to the power of n, and it is given it is not uniformly convergent. It is not uniformly, this statement is not uniformly convergent. Let us see. If it is not uniformly convergent, this statement is true. If it is uniformly convergent, then the statement is not true. We have Fnx. And for each x belongs to n, let's talk about pointwise convergence. Limit n tends to infinity of Fnx is limit n tends to infinity of x to the power of n by 1 plus n x to the power of n is 0. That is f of x. That means f of x is 0 for all x belongs to 0 to 1, f is the limiting function. Therefore, this sequence converges pointwise to f on 0 to 1. Agreed. Agreed. Is it uniformly convergent? For that, we have to apply M test. So, we first calculate Mn. That is the supremum taken over x belongs to open interval 0 to 1 of mod of Fnx minus Fx. It is the supremum of x to the power of n by 1 plus nx to the power of n. And again, x to the power of n is involved here. So, we go and put phi of x is equal to x to the power of n by 1 plus nx to the power of n. We differentiate with respect to x using the quotient formula. Simplify, we get nx to the power of n minus 1 by 1 plus nx to the power of n whole square, which is greater than 0 for all x belongs to 0 to 1. Therefore, it says phi of x is a monotonically increasing function. When it is monotonically increasing function, supremum is given by supremum of x belongs to 0 to 1, x to the power of n by 1 plus nx to the power of n is 1 by 1 plus n. So, we go back and the Mn is supremum is 1 by 1 plus n. Now, we get the sequence Mn. So, let limit n tends to infinity of Mn is limit n tends to 1 by 1 plus n is 0. Agreed? Agreed. So therefore, by M test, the given sequence is uniformly convergent. It is uniformly convergent. But in the statement it is given it is not uniformly convergent. Therefore, option 4 is not true. Summarizing all the options, the answer to this question is option 2. That is the detailed discussion of the solution of the given problem from the section real analysis, which is related to the uniform convergence of sequence of functions. And it is definitely not a difficult problem. It is an easy question. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We will meet once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.